Good morning, everybody. Happy Monday. Hopefully everybody's doing well out there and you had a good weekend. If you could start with some green check marks, please, we'll get started. And if you did anything exciting on this weekend, you should probably put that into chat as well. I didn't do anything exciting this weekend. In fact, I didn't do very much at all. It's quite boring. But that's okay. Anybody go camping, fishing, hiking, walking in the forest? Thanks for the green checks. Sick. Sick isn't a good place to be, but if you think about it, you got some Walking Dead out of it, so that was okay, I bet. Jenny did math all weekend. That's fantastic. That's good news. Went to Vancouver. It's always fun to go down there to realize how crazy Vancouver is and how nice Kelowna is. Puts everything in perspective, I find, when I leave the Lower Mainland and I'm like, wow, I'm so thankful I don't live here. Nice place to visit. All right, so as we left last day, I was kind of pushing everything back a day. So instead of giving you guys the weekend to get everything done and submitted, I wanted to go through a few additional problems. I didn't get to any of the sphere questions, and there's some kind of word problem type questions that I wanted to go through as well. So I want to do that now. Just a reminder, you should probably be finished your learning guide for Unit 2 either today or tomorrow. You should be nearly done it. And when you submit it, you need to submit it all as one file. So if we're in the course, there's a couple suggestions for apps for your phone where you just take pictures of each of the pages. It'll combine it all into one PDF file, and then you can just submit that. I don't really care if it's a PDF or a Word document or whatever the case is, as long as you're just submitting it as one document. Some people take pictures and then they put those pictures into like a Word document for each of the pages. That's fine as long as I can read it. I find the Cam Scanner or TinyScan does a pretty decent job of taking pictures that I can read and see. So if you're having issues with that, send me a message and we'll get through it. There's like 9 or 10 units and you're gonna have to do this for every single one. So if you're having issues with it, let's figure it out now so we don't have to worry about it in Unit 2 and 3 and 4 and 5 all the way through the course. So it is what it is. Just get the stuff in. We can figure out a way. Don't email it to me. Use the submission box in the course. So again, we're going to go through a bunch of questions today, but when you're ready to submit your learning guide, this is Unit 2. This is what we've been working through. All the lessons are there. Right at the bottom, Unit 2 Learning Guide Dropbox, submit on September 30th, which was last week, but then I said, hey guys, I'd like to go through a few more questions today. So I bumped that back a day, so it should be done today or tomorrow. And then your exam says October 3rd, which is today, which should probably be like Wednesday now. So anyways, to submit your learning guide, you go into the assignment. You guys have probably done this with Mrs. Ward or Mrs. Wood for some of your planning stuff, but you go down to the very bottom, and you guys probably don't see as much of this stuff, but where it says add submission, and you open that up, and then you have to scroll down again. So you can drag and drop into this box where the arrow is, or you can click on the little plus sign next to this little file here. And both those will allow you to add that document. So that is how we are going to submit the Unit 2 Learning Guide. Ian and Leeds, yeah, I will definitely go through that problem with you guys. So that's when you're going to get your learning guide into me. It just makes it easier. I can go through them all at once and mark them together, which makes my life easier. If you run into problems, let me know. We can figure it out, but hopefully you can sort that out. I have a feeling you guys are probably experts at submitting stuff now, so that's at the bottom of Unit 2. Thanks for putting in questions. If there's any other questions, number 4 on page 10, I'll definitely go through. Anything else you want me to go through, you can just throw it into chat and I'll do that. And then once we've gone through this or other questions, I will go through a few of the volume questions from the sphere stuff, surface area volume of spheres. And then I think that's it, because we've done the composite shape stuff already. For sure, Jen and I can get to that as well. So let's start with number 4 on page 10. Page 8, page 9, 10. Yeah, this is a good one. And it's kind of my fault for you guys not being able to do it right yet, because we started with unit 2 and unit 1 was the radicals unit, so you kind of need to know a little bit of stuff. Some people know it from grade 9, but others don't. So I will definitely go through this one, and then Jen asked for number 3 on page 11. I love this question as well. Definitely a good one. So I'll go through those for sure. All right. So we have a right rectangular prism, which is just a fancy word for saying like a box. So here's our right rectangular prism. There we go. And it says our edge lengths are 3, 5, and 8. So let's make this 3 x's long. We'll make this 5 x's long, and then this one 8 x's long. All right. It tells us that the volume of the shape we've drawn, our right rectangular prism, is 7,680 inches cubed. So we know the entire volume of the shape. We know the lengths of all the sides, but there's this x in there, and we don't really know what x is. But we can probably figure it out because we have the volume. We know how big this thing is. So if you recall, to find the volume of a right rectangular prism, the volume is going to be length times width times height. All right, that seems pretty straightforward. And length, width, height for a prism doesn't really matter what order we put them in. So let's just substitute these values in. I have 3 x's, and I'm going to multiply that by 5 x's, and then I'm going to multiply it by 8 x's. All right. What am I going to do now? I have x's in there. I only know what to do with numbers. There's a variable in there. So confusing. Well, let's just multiply it all together and see what we end up with. So we're going to take our, I'll just continue it up here. The volume is going to be 3 times 5 times 8. So 3 times 5 is 15 times 8 is 120. What about x? If I had like x times x, what does that equal? Or if I had x times x times x, what does that equal? When I multiplied my x's together, what happens there? Do the x's disappear? Do they add together? Multiply them? Do they explode? I'm going to remember how to multiply variables. That's definitely something you probably saw in grade 9. We'll be doing a whole lot of it in grade 10. So if you recall how to do that, that would be a very good thing. They do not cancel out. If you had one on the top and then you divided by x, they would cancel out. But because we're multiplying them, we have a situation where we end up with exponents. So x times x is x squared, and x, so if I lost one of these x's, x times x would be x squared. And then if I had 3 x's, x times x times x, that'd be x to the power of 3. Thank you, Jesse. So that's x cubed, you got it. All right, so I have 120 x cubed. So we've done a little bit of stuff with x squared so far, or a variable squared. But now we have an x which is cubed, so makes things a little bit more challenging. Now, I'm kind of stuck. I can't go any further. I've multiplied my length times width times height. I get 120 x cubed. But I do know that my volume was 7,680. So I'm going to plug that in for v. So instead of v is 120 x cubed, I'm going to have 7,680 is equal to 120 times x cubed. Okay, I'm trying to figure out what x is. That's what the question's asking me. Right in the question it says, what is the length of each edge? So I'm trying to figure out the length of the edges, and they're 3 times x, 5 times x, and 8 times x. So if I knew what x was, I should be able to finish this question off. So we do some algebra here. We need to isolate x. We need to get x by itself. So this kind of goes into the opposite of BEDMAS. Whatever you're doing to x, you're going to do the opposite. So if I'm multiplying x by 120, the opposite is going to be dividing by 120. And if I do it to one side of my equal sign, I have to do it to the other side of my equal sign. So over here, 120 divided by 120 just divides out and gives me 1, or cancels. That's what Jenna was talking about before. And then I have 7,680 divided by 120. I've run out of room again. So 7,680 divided by 120 works out to be 64, which is equal to x cubed. If only there was some way I could get rid of that cubed. We've done this before where we had something is equal to x squared. The opposite of squaring something is taking the square root of it. If we are going to take something like x to the power of 3, the opposite of that will be taking the cube root of that. Now I haven't talked about cube roots yet. Has anybody heard of a cube root before? Basically like a square root, but we put a little 3 in front of it. And we'll talk a little bit about what that is later on. But essentially what we want to think about is a number that's multiplied by itself 3 times, so like 2 times 2 times 2 is 8, or 3 times 3 times 3 is 27. In this case, we want to figure out a number that multiplied by itself 3 times that's going to give us 64. So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 is 16 times 4 is, does that work out right? 4 times 4 times 4. There you go. 4 times 4 times 4 is 64. So 4 multiplied by itself 3 times is 64. So the cube root of 64 is equal to 4. Now, if you don't believe me, that's fine. What we can do is, on our calculators, if you have a scientific calculator, you probably have a cube root button. Or if you don't have a cube root button, you might have a button that looks like, it could have a little X in front of a square root sign. You could have a button like that. Or you could have a button that looks like, some calculators do have a cube root button. Looks like that. Sometimes you have a y to the x button, and then you have to hit the shift before you hit the y to the x, and that'll work out for you. So if you have a button like this with the little x in front of the square root sign, you probably have to put in a 3. That's how mine works. And then I hit the x with the, I have to go second x in front of the square root, and then 64, and then hit equals, and it gets me 4. I'll have a look here in a second, Ian. So if you can or cannot find that button, that's okay. Do your best to see if you can find it. and see if you can put in the cube root of 64 and see if you get 4. That's how you know you're doing it right. Everybody's going to be a little bit different depending on your calculator. It just depends on what button you end up with there. So the question actually asks how long was each side. So we know that each side is 3x, 5x, and 8x, and we know x was 4 now. So 3 times x is going to give us one side's 12. 5 times x, you get the idea. So the answer is going to be a little bit different than, it's not just 4, but you can multiply 3 by 4, 5 by 4, and 8 by 4 to figure out how long each of those sides were going to be. Let's go up page 8, number 6. Yes, I did ask you to do that one. And I gave you guys a little hint on that one as well, Ian, that when you're finding the surface area, trying to cover the pile of dirt with plastic, you don't need to use the circle on the bottom as part of the surface area, just the lateral area, which is going to be pi rs. So that should have been straightforward, hopefully. Kind of plugged through this, did that. Hopefully that helps you guys out for number 4. Number 6 is a really good question too. It's asking if we triple the dimensions, so the length, the width, and the height, what happens? Square-based pyramid. Yep. What happens to the volume? So what you can do, because no numbers are given, you can just put in imaginary numbers. So let's say that I have a square-based pyramid. I'm going to successfully draw a square-based pyramid. There we go. That wasn't bad. Pretty happy with that, actually. We could make the bottom length like 1, and we can make we can have the height here. We can make the height 1. And then we can draw the exact same pyramid again, except we're going to triple it. That one didn't work out so well. That's okay. Now we're going to triple the length. So I'm going to make it 3. And I'm going to draw on my height, and I'm going to make that 3. And just do the question again, find the volume again. So find the volume of this guy, figure out what that equals, find the volume of this guy, and figure out how they're related. A little bit of work, or you can look at the formulas and try to figure it out. But that's definitely a good question. Now, Jenna asked about one of the volume questions. Calculate as requested, showing equations in all work. So this is volume and surface area of spheres. If you jump to your formula sheet that you carry with you everywhere you go, you can see that we have volume and surface area of spheres here. Volume, surface area is 4 pi r squared, or pi d squared, depends if you have the diameter or the radius, and then the volume is 4/3 pi r cubed. There you go. Those are the 2 formulas, or 3, that you need to know for this next section. So I think you'll be okay with number 1. Yeah. I want to help you guys set up number 2. I think you guys should be able to do it, but let's just make sure. I'm just going to draw it in kind of 2 dimensions first. So we have this orange sphere. It's a very good circle. Okay, I'm happier with that. There we go. So that's what it looks like. And it says the diameter of the outside is 2 feet. Now I'm going to give you guys a little hint here. It's 2 feet, and then it says it's 1 inch thick. So let's just convert this to 24 inches. Each foot is 12 inches. 2 feet is 24 inches. So the diameter. So we're talking edge to edge here. this is the outside, is 24 inches. Okay, can handle that. Maybe I'll just draw in a line here across the circle. 24 inches. Now, the inside is actually hollow, and that's how it's going to float. Good enough. It says it's 1 inch thick, so this is 1 inch. So if I wanted to do the diameter of the inner circle, the green line here, how far would that be across the green line as opposed to the blue line? Essentially, you're going to have to do 2 volume calculations, and then you're just going to have to subtract the inside from the outside. Any ideas that green line, how far it is? If the blue line's 24 and then the thickness is 1 inch on either side, it's going to be 1 inch smaller, and Jenna has it at 22 inches. There you go. So what you're going to have to do is take the volume of the outside, and then you take the volume of the inside, and then subtract the inside from the outside. That should get you going on that one. If I'm not mistaken, I think the answer to this question used to be wrong. So if you get to the end and your answer's wrong, it's entirely possible that they haven't fixed it yet. Usually after each year, they kind of update the answer keys and things like that for any mistakes they made. So it's possible that that one's still wrong. I don't know. We haven't looked at the answers yet. Okay, okay. Number 3, we have a box or a rectangular prism. See if I can manage to draw a rectangular prism. This isn't looking great, but it'll have to do. There we go. So we have this box, and inside the box we have some golf balls. There's 1 golf ball, 2 golf balls, 3 golf balls. And then if I go work my way back, I have 1, 2, 3, 4. So you can imagine that that container is full of golf balls. You've probably seen something like this before. I didn't draw a very good job on the inside there. But just for the, let's just focus on the front here for a second. All right. The golf balls are packed tightly together. They touch the top and bottom and sides of the box. What percentage of the volume of the box is air? The thing that most students have issues with on this problem is that there's no numbers given. You're like, oh no, I don't know how big a golf ball is or anything like that. What I would suggest is you can think about it in terms of numbers if you want. You can just make it up. It doesn't matter. Or you can put in a variable. So normally when we talk about spheres, like a golf ball, we have the distance from the center of the edge. We call that r. So if I have a golf ball that has the radius r, if I go all the way across the golf ball, I have 2 r's. And then if I have another golf ball, that's another 2 r's. So we're up to 4 r's. And then 6 r's. Sound like a pirate. 6 r's. So if I went all the way across from one side to the next, I would have 6 r's. R. And if I wanted to go from the top of the box to the bottom, that would be 2 r's is this side. And then if I wanted to go back, it says there's 12 golf balls, so I would have 4 going back. That means I would have 8 this way. Now this kind of looks like the question we did at the beginning of class where we had all of those variables. Instead of having my length and width and height in terms of numbers, I had 3x, 5x, and 8x. This question, I have 2 r's for the height. I have 6 r's to go across, and then 8 r's for my length. So if I wanted to find the volume of this thing, I would go 2r times 6r times 8r. So that's the volume of my, let's, instead of just writing volume, I'm going to draw in a little rectangular prism type deal. Okay, what about the volume of my golf balls on the inside, or the volume of my sphere? Well, that's going to be 4/3 pi r cubed. But how many golf balls do I have? Well, I have 12 of them in there, so I'm going to have to multiply that by 12. Don't like using that x. Let's just put in brackets. I have 12 golf balls. So we could probably figure this out, and we could probably figure this out. And then the idea is that we're trying to find the percentage of the volume of the box's air. So if I know the volume of my box, and I know the volume that my golf balls take up on the inside, if I could divide those things, or I guess I'd have to subtract first and then divide them, that would give me the percentage of the box that's air. Shall I continue, or do you think you can go from there? What do you think? Keep going, Mr. Borden. Stop, Mr. Borden. Keep going, Mr. Borden. No, I can do it. Let me do it on my own, Mr. Borden. I don't need you to walk me through everything. Just continue to talk to myself. Keep going. All right, Jesse, we'll keep going. So the volume of the box, let's figure that out first. Don't stop. Keep going, Mr. Borden. You can do it. 2 times 6 times 8 is 96. So the volume of the box is going to be 96r cubed. And then the volume of all of my golf balls is going to be 12 times 4. I'm just moving the 12 to the front, times pi times r cubed. And I'm going to do this 12 times 4 divided by 3 thing. 12 divided by 3 is 4. 4 times 4 is 16. So 12 times 4 divided by 3 should give me 16, and it does. So the volume of my spheres is going to be 16 pi r cubed. Okay. So I know the volume of all of my golf balls. I know the volume of the box. And then the question asks, what percentage of the volume of the box is air? Now, I could calculate this all in terms of r like I've done. I could take this guy and say, okay, 96r cubed subtract 16 pi r cubed. That all gets kind of confusing. So why don't I just say, let's just make up a radius. This makes the most sense to me. Let's just go like this. Make some room over here. Why don't we just say that r, the radius, is equal to 1? The question didn't tell me how big the golf balls were, but it doesn't really matter. Because we're trying to find everything as a percentage, it doesn't matter if the golf ball was 1 centimeter radius or 20 centimeter radius. The answer is still going to look the same. So why did I pick 1? Well, if I go here, the volume of my box is going to be 96 times 1 cubed, which is just going to be 96. And then the volume of my sphere is just going to be 16 times pi times 1 cubed, or just 16 times pi. And I don't know, let's just figure out what that is as a decimal. Pi times 16 is 50.27. All right. So I need to figure out the percent that's air. I know how big the box is. The volume inside is 96. The golf balls fill up 50.27 of that 96. So if I need to figure out the amount of air in the box, I'm going to take my box, 96, and I'm going to subtract 50.27 because that 50.27 is the golf balls. So 96 minus 50.27 is 45.73. Is air. Now, this is where the question's kind of tricky because it doesn't say what is the volume of air in the box. That's what we just calculated. We knew the box was this big. We knew that the balls took up this much space. We subtracted them. We figured out how much volume is air. But the question says what percentage of the box is air. So if we have the whole box is 96, and we know that 45.73 of it is air. To figure out the percent that's made of air, we're going to take that 45.73 and we're going to divide it by 96. And we get 0.4763. Or, if I convert that to a percent, 47.6%, if I just multiply it by 100. So 47% of the box, 47.6, is made of air. Now, you could have put in a radius of 27 if you wanted, and you would have ended up at the same sort of spot because you are finding things in terms of percent. So it didn't really matter what the radius was. You could have figured it out in terms of variables if you wanted, and it would have worked out the same, but it just kind of made sense to, because it didn't really matter how big the balls were, we just wanted a ratio or a percentage, to just kind of plug away like we knew what the number was. And if you're not given numbers in a question, you can often just put in numbers and figure it out if you like working with numbers as opposed to variables. I guess it kind of depends on what the question asks. So I really, really like that question. I think it's fair. It's challenging, but I think it's fair. It asks you, it asks you some things. It doesn't give you numbers. I guess that's where a lot of students kind of get hung up. But you can find the volume of the box. You can find the volume of each of the 12 balls inside. The only thing you need to know is something to relate the volume of the box and the spheres or those balls, and that is the R. So the key thing was what I did right at the very beginning when I said, okay, let's find the volume of the balls and the box, and we need to have something in common, shared between those. If you don't have something common, you wouldn't be able to do it. But we know that the sphere, that golf ball, touches the top and bottom, so it's 2 R's, and then 6 R's, and then 8 R's. That's the key here. All right, we're doing okay for time. I think there's likely a few more questions I'd like to go through. Is everybody doing okay? Do I need to go over anything a little bit more thoroughly, or are we okay with what I've done there? You'll notice that the questions on page 12 start to get a little bit, I don't want to say tricky, but a lot of you guys have done surface area and volumes of spheres in grade 9 already. So instead of asking, what is the volume of this sphere? And then you find the radius and then you plug it in and you get the answer, 4/3 pi r, 4/3 pi r cubed. They kind of ask you to use the volume, but they don't want you to just simply calculate the volume. So if we look at number 4, the radius of a sphere is 10, and of a cone is 5. The volumes of the sphere and cone are equal. What is the height of the cone? So you need to take the volume of the sphere and then make that equal to the volume of the cone because their volumes are the same. And then you have to kind of work backwards and find the height. I can definitely go through that. Jenna is asking which ones on the later pages are we not supposed to do? Let's flip that around and make it positive. Which ones are we supposed to do? So this is page 12. I asked you guys to do number 4 and 5 on page 12. And then the irregular shape stuff, we've already done these questions. So I asked you to do them 2 weeks ago when we were all together. These are kind of composite shapes ones. I think I did 2 and 3 in class, and then maybe 5 I did as well. So you've already seen these questions. So basically what we have left is 4 and 5, and then that's it. So what I would like is to maybe, how about I give you guys time to do 4 and 5, and then if you run into problems, then you can ask. But really that's kind of it for the second unit. I just wanted to go through a few of these additional ones, and I had a feeling you guys would have some questions. Yeah, maybe I'll give you guys like 10 minutes or so to go through 4 and 5, see how you do, and the questions can get a bit tricky, so just, you know, see if you can come up with answers. I'll do one of them. Maybe we'll see who, if you guys have troubles with one or the other. And then we'll probably just end there. There's nothing really else I want to do from this unit. I'm sure you guys have some questions. I'd love to go through them. Even if you have a question that's not related, well, a question that's not directly out of the learning guide, something that you've just kind of encountered, or if something in the learning guide you had a question about. Essentially, it's kind of your opportunity to finish up the learning guide and then be able to submit that today or tomorrow. And I'd like to move on to Unit 1, so we kind of take a step backwards into Unit 1. So I'd like to do that next day, so that's my hope. So I'm going to give you guys, what did I say, 10 minutes, and go through 4 and 5. If you run into problems, I can do them for you, but hopefully you guys can get them. And then if you had any other questions about Unit 2 that you wanted to ask before you submit your learning guide and before you guys attempt the quizzes that are in the course and the test. So put up 10 minutes, come up back with questions, and then that's kind of going to be it for Unit 2. So we'll see you guys back in 10. Thanks. Hi guys, welcome back. Let's just go with green check marks. I see Jeremy's made it in, but he said he can't get the live feed up, so we're gonna, he won't be able to hear what I'm saying. That's too bad. I'm just gonna send him a little message here. Sorry about that. Thanks for your patience, guys. I was trying to get Jeremy set up. All right, looks good, looks good, looks good. Okay, did anybody run into problems with 4 or 5 here, or anything else for that matter in Unit 2? Think of this as kind of like your last opportunity to ask questions from Unit 2. I'll be happy to go through anything. We have about 25 or so minutes left, maybe 20 minutes so I can get ready for my next class. And yeah, we'll be happy to go through anything. I mean, next, you got stuck. Which question, 4 or 5, Jenna? The beginning of next class, if you do run into problems and you want me to go through them, I'd be happy to do that. But I really would like it to kind of get through Unit 2 because I want to get into Unit 1 and I want to get into a bit of a routine because this whole thing is just kind of bouncing back and forth all over the place. It's really disjointed. I don't like it. So what I want to do is start a fresh unit and give you guys the learning guide, give you guys the lessons, and get you guys to print all that stuff, and then we can just kind of work through it together. We're not doing a bit of this and a bit of that. We're just kind of a little bit more organized. I don't like being all over the place. So I'll do number 4, and then that might help you guys out on number 5. Remind me before I leave to remind you guys to print off the Unit 1 learning guide as well as the Unit 1 lessons, which I will unlock here in a little bit. Can't forget, gotta remind me. The radius of a sphere is 10, and the radius of a cone is 5. Okay, so it's telling us kind of 2 things, and we need to kind of, relate them. So obviously not a sphere, but a circle, but it tells me that the radius is 10. And then I have a cone. Here's my cone. And the radius of a cone is 5. And it's asking me to find the height of the cone. And I don't know what the height is. So it's kind of my question mark here. Okay, let's start by kind of figuring out what we need to do. So the volumes of the sphere and the cone are the same. They're equal. So what I can do is I can make them equal in terms of their formulas, or I can figure out the volume of the sphere. Let's just go volume of sphere. I know the volume of a sphere is 4/3 pi r cubed from my formula sheet. Radius is 10, so let's figure it out. 4/3 pi 10 cubed. It's going to be a big number. That's okay. 10 times 10 times 10 is going to be 1,000 times 4 divided by 3 times pi. We're going to get 4,188.8 centimeters cubed. So that is the volume of the sphere. We also need to know the volume of the cone. And I'm going to just jump over to my formula sheet because I don't remember what the volume of a cone is. So it says right here, volume is 1/3 the area of the base times height, and the base is a circle, so I don't know why they don't just write in pi r squared, because all cones have a circular base, else it wouldn't be a cone. Anyways, so 1/3 pi r squared times the height. Let's jump back here. 1/3 pi r squared times the height. Okay, I know that the radius is 5. It told me that in the question. And then I'm just left with this height. Maybe I'll make it red so it kind of stands out. Now, the volume here is equal, right? The question told me these volumes were the same. So what I'm going to end up doing is I'm going to make these things equal. But before I do that, I'm going to calculate what 1/3 pi r squared is. So I'm going to go pi times 5 times 5 is 25, and divided by 3. It's 26.17, we'll just call it 26.2 times the height. Now I know that the volumes are equal, so I'm going to make them equal. So 4,188.8 is equal to 26.2 times h. I want to get each by itself. I'm multiplying. I want to do the opposite. I'm going to divide both sides by 26.2. So 4,188.8 divided by 26.2 is 159.87. Seems like a really, really big number. Make sure I didn't make a mistake anywhere. 4/3 pi r cubed. Does anybody see if I made a mistake anywhere? That's looking all right. 25 times pi, 26.17. I'm thinking that's okay. It just seems like a really, really tall cone, but I guess the volume of that sphere was really big. Not much we can do about that. 4,188.8 times 3 divided by pi. Sorry, I'm just working through it again. Yeah, I get the same answer twice. So there we go. We'll just call it 160 centimeters is equal to the height. Did anybody have any further questions? Anything at all from Unit 2? Something you wanted me to go through, something you didn't understand, using one of the formulas, anything. If you don't have any questions, then I will probably just leave it there. You were to remind me about something in the course. Unlock Unit 1 and open up the learning guide and the lessons. So For Unit 2, I kind of had this sheet and that sheet and this sheet and that sheet, and I said, we're going to do this, and then I uploaded a day before because I was kind of trying to make everything work, and it didn't work. So what I'm going to do for Unit 1 is there are going to be 2 booklets you need to print. One of them is going to be the learning guide, and the second one is going to be all of the lessons for the entire unit. So I'm not always just going to work through the learning guide with you guys. Generally speaking, the learning guide will be something that you guys do on your own, and if you have questions, I'll go through them, but I won't do examples out of the learning guide. So for Unit 1, before the end of the day today, I will unlock Unit 1. I will unlock the learning guide and the lessons. So it'll say Unit 1 lessons, print them all, and Unit 1 learning guide, print it all. So the learning guide will be, 20 pages or whatever, 10, 15 pages, and the lessons will be, probably about 7 to 10 pages as well. So you guys should print those off for next day. One kind of thing, if you're new to our program, it's a bit different, especially with math. Normally, if you were in a regular classroom, like in a building, you would go to class, you'd sit down, you'd write the test. But I'm going to assume that you're going to do the test on your own time. I'm not going to, set aside time for you to do the test. So what you need to do between hopefully now and Wednesday is submit your learning guide. Hopefully by the end of today or tomorrow, I'll send you guys the password to your parents, and then you'll have to find some time to sit down and write the Unit 2 test. And I think it's 20 questions. They're usually about 20 questions or so. And there's no timer on the tests. You can take as long as you want. It's closed book, and you can have your formula sheet out. So that's kind of what the test looks like. If you do run into problems with a question, like, I didn't cover it, or the answer you got was wrong, or it asked you to put in a number and you put like 19, but it was 19.0, just hit the little flag next to it, and then when I go in to see the results of the tests and how everyone did, I will go into all of the flagged questions and I'll check them and make sure that what you did was right, or if you made a silly mistake, I can override the grades that the computer gives you. So that's kind of the test process. So important things. Finish all the quizzes. There's 4 of them in Unit 2. Submit the Unit 2 learning guide. Write the test. This doesn't all need to happen today. I know some of you are perhaps a little bit further behind, and some of you are ready to write that test. So I'm going to give you guys some flexibility in your schedules. But I have to have you guys done the tests on Wednesday. So Wednesday would be kind of the end for Unit 2 test. So next day, if you have some really, really last minute questions that you want to go through on Wednesday's class, I can go through it. But I would like everything to kind of be done by Wednesday. So hopefully you can sort it out on your own. If not, send me a message or whatnot and I can help you out. Submit the Unit 2 learning guide, write that test. We're going to start Unit 1 on Wednesday's class, so you should have the learning guide for Unit 1 printed and the lessons for Unit 1 printed. I will have those uploaded before the end of today's class. If you want to come in and pick them up, send me a message. I'll print them off for you. Whew. Does anybody have any questions before we leave for the day? Anything at all about tests, submitting, learning guides, Unit 2? If not, I will leave you guys there. And yeah, we'll see you guys on Wednesday. Of course, Friday this week is a professional development day for the teachers, so there's no field trip on Friday because I think we're at Rutland Secondary or something like that. So no field trip this Friday, which is kind of sad. I always look forward to Fridays. I don't always get to come on the field trips, but when I do, they're fun. All right, nobody's put in any questions. I've killed enough time. Have a great afternoon. Enjoy the sunshine if you can, and I will see you guys back on Wednesday, and then hopefully I start to see some learning guides being submitted, and we'll get the test written by the end of the day Wednesday. So have a great afternoon, and we'll see you guys then. Bye-bye.